Okay, let's take a look at section 1.3, exercise 24. So in 24, we're asked to just find these limits. We're told that f of x is equal to x plus 7 and g of x is equal to x squared. And in A, I'm asked to find the limit as x goes to -3 of f of x. Well, that's equal to the limit as x goes to -3 of x plus 7. And I can do that by direct substitution. So I get my -3 plus 7, and that equals 4. And here I write by ds, direct substitution. Okay, B, the limit of g of x as x goes to 4. Well, that's the limit as x goes to 4 of x squared, which is 4 squared by direct substitution, and then that's 16. Okay, and C, we want the limit as x goes to, kind of lost it there, -3. Limit as x goes to -3 of g of f of x. Okay, well then that is by our composition, right? We need the limit as x goes to -3 of g, what the heck was f of x? 2, I don't know, x plus 7. And that is the limit as x goes to -3 of x plus 7 squared, which we can do by direct substitution if that's what we want to do. And so this is 4 squared 16. They're just having us do A and B up there. This is -3 plus 7 squared by direct substitution, which is equal to 4 squared, or 16. Okay, so we can do that that way, but we can also use our theorem, in which case we have the limit as x goes to -3 of g of f of x. Then what we can say here is that we believe that this limit is equal to g of the limit as x goes to -3 of f of x. Well, didn't need that one. Okay, so we have that, but then that's g of 4, which we know is then 16. But here, actually, to use that theorem, to go, so here we used theorem 1.5. Okay, to bring that limit inside the g function. But then we sort of used that theorem 1.5 again here because, so this is theorem 1.5 since the limit as x goes to 4 of g of x is equal to 16. So we had to know that that limit existed, but we saw that up in part B. Okay, so you could simply, as you think through the problem, you could be thinking up here this way is, just what is the composite function? It's this thing here, which I can do by direct substitution, or you could think of it in terms of the theorem that I'm allowed to take that limit inside g of x here and evaluate the limit as x goes to -3 of f of x to get 4, and then just evaluate g of 4. Well, as long as I realize that these things are true, that the limit as x goes to 4 of g of x is 16. Okay, so you just want to be careful of those types of things. Okay, so that was, what that problem was that? Section 1.3, number 24. And we can get those. All right.